Question 7. A wood-burning stove is used to heat a room. The fire in the stove uses wood as a fuel. The fire heats the matte black. Now we've got to remember some stuff about matte black. Metal case of the stove. The NX stove is warmed by infrared radiation. How does the design of the stove help to improve the rate of energy transfer by infrared radiation? So let's look at this again. It has a large surface area, okay, and we should remember that things that are black and things that are matte are good emitters of IR radiation. Okay, so I think the points, it's 2 marks we need to make. It's 2 marks we need to make 2 points. The 2 points that I would make is that both black colour and matte surface ensure excellent emission of infrared radiation. Okay. Metal is a good conductor of IR from inside to out, and if we want to get there, finally, just to make sure we've nailed it for the 2 marks, the stove also has been designed to have a large surface area. So black, matte, emission, excellent emission of infrared, metal, good conductor, and large surface area. Right, we're going to refer back to the physics equation sheet in a second here, so always use it where it says use it. 1 kilojoule of wood transfers 15 megajoules of energy to the stove then transfers 13.5 megajoules of energy to the room. Efficiency, we're looking to look at the efficiency. Right, formula sheet, efficiency, could be this or this. We're talking about energy, so energy out, energy in. Energy out over energy in, and I've actually saw that as well, I didn't stress it, times 100. We're looking for an answer as a percentage, okay, so times 100. So if we do that, efficiency is equal to 13.5 divided by 15. Don't worry about the megajoules, it's not important, they're both in the same unit, so it doesn't matter. All we've got to worry about is the values, not the actual units that they're in. 13.5 divided by 15 times 100, and if you do that, you should get 90% efficiency. Now, you could either write 90% like that, or 0.9, okay? That would be the one I'm recommending, because it's telling you by timesing by 100, it's to do with percent. If you just put 90 without that, you're not going to get the 2 marks. If you put 0.9 and you've got all your working here, you would. Okay, some of the energy from burning wood is wasted as hot gases, leaving the chimney and warm the air outside. Name one other way energy is wasted by the stove. If you think about a fire, the main thing that you're getting is heat, but there's also light. And if you didn't put light, Another answer you could put was sound, as in terms of the crackle of an open fire. So one of those, either or. You have to put both, but the best one's probably light to go for. Some people heat their homes using electrical heaters. Other people heat their homes using a wood stove. 2, and it tells you it's 2. 2 marks. Environmental advantages. Right. If you're telling me that it looks pretty, if you're telling me it's cheaper, that's not environmental. Okay? Things that are environmental would be, we're using wood instead of fossil fuels. Yeah? The other thing that you could go on to mention is carbon neutral. Okay? So you could say that. You could say that it's renewable. It's a renewable source. We can chop down trees and grow them back and renew and renew and renew. And carbon neutral means that the tree here, as it's growing, takes up CO2. When we chop it down, make some logs, and then burn those logs, the CO2 that was taken in is then released back. So there's no net increase in carbon or CO2 in the atmosphere. Those are 2 environmental reasons or advantages to it. That wood is renewable, okay, we're not burning fossil fuels is another reason, and it's carbon neutral. Okay, final bit. Metal case, it gets hot. Sorry, metal case on fire gets hot when it's lit. Information about the stove. Okay. Physics equation sheet. Okay, we've got mass. Okay, we've got a change. And we've got the specific heat capacity. Let's see if anything, this is the one that's going to give it away for you though, okay, ties in with anything on here. That's our equation. E is equal to m times c times theta. Calculate the energy required to raise the temperature of the metal case to 70. Okay, so the starting temperature was 20. So what's the change from there to there? 20, 70 take away 20 is theta is equal to 50 degrees. Mass is 100, specific heat capacity is given to us. Okay, so we're going to show how you work out your answer and give the unit. Yeah? Unit, what we're looking to calculate. Energy. So kilograms, unit of mass, degrees Celsius, unit of temperature, kilograms, mass, temperature. What's this? That's a joule. So we've got our unit as well. And make sure you write J with a capital J, not a lowercase j, because there's no such thing. It's got to be an uppercase J for the mark. So already we're almost like 2 marks here. All we've got to do now is substitute in the values. So 100 times times 510, okay, times 50. Okay, so if we work that out, we should find that the energy required is 255000 joules. Write it in the space provided, make it nice and easy for the marker. If you want to be smart, that's joules, remembering that a kilojoule, anything into kilos, we're taking it up to kilos, we need to get rid of those there. Okay, remember that's a comma, 2550 kilojoules. Either answer will suffice.